Let's do an example. Okay, so we're just coming off from the 5 steps that we've written down from the previous video. And so now we have a rational function. So notice we have a numerator denominator -4 over x squared plus x minus 6. And so usually when there's a negative, I usually like to just scratch that and put that on top. It just makes it easier for my calculations, although you do not have to. Okay, so and then we're going to have this graph. I'm just going to start doing the steps below or anywhere you guys find the paper. Number 1, let's start off with our vertical asymptote VA. And again, how to do that. We're going to set the denominator equal to 0. So I'm just writing the steps down on the side so you guys don't have to keep flipping over here. So let's take a look at the denominator. It's x squared plus x minus 6. So x squared plus x minus 6. We're going to set that equal to 0. And then from here, hopefully it looks like some of your problems that you have revisited before the past 2 weeks, because then we're going to have to factor this part over here. I believe we're going to go x plus 3 and x minus 2, if I'm not mistaken. Let's try -6, and then yeah, positive 3 minus 2 is going to equal to 1. So this is going to be it. Okay, then we're going to do ZPP. X plus 3 is equal to 0. X minus 2 is equal to 0. Okay, and then I think I'm going to color code this one. Yeah, let's just do vertical asymptotes. So x equals -3, and then x equals positive 2. Minus 3 on both sides, add 2 on both sides. Okay, I want to put in a note over here. These are not points. These are lines. You know, some people are going to go -3, 0 or 2, 0. No. So these are lines, vertical asymptotes, okay, that go like that. Or we can draw that in a little bit. Okay. I think I just kind of like to just kind of make borders. So I'll just make a border over here. We are done with step 1. Step 2 now is we're going to do our horizontal asymptote. And by doing that, we need to check the highest powers. And so I think I'm just going to rewrite the important ones over here. So I'm just going to rewrite the equation, but like the highest. So the highest power on the bottom is x squared. Okay. On the top, we don't have an x, but technically we have an x to the 0. Okay. All right, take a look. The degree on the numerator, is it equal to or less than? It is actually less than the degree in the denominator. Denominator, oh boy. Okay. Because of that, therefore, your horizontal asymptote is y is equal to 0. Okay. Will there ever be a case where the numerator is greater than the denominator? And the answer is yes. We will get to that, but not now. So that will be the third reason when we get into the next notes, okay? But for right now, on these problems, I'm only going to make it so that either the numerator is equal or the numerator is less than the degree of the denominator. There will be a case when it's greater than, but not right now. Okay, so anyway, it is less than, and so we're going to go y is equal to 0. Let's go ahead and start graphing those horizontal and vertical asymptotes. Yeah, let's go ahead and do it. So x equals -3, which is over here, and I'm going to make that in red. Bam, bam, bam. Okay, and then we also have x is equal to 2. Okay, so we're done with those, and then after that we also have the horizontal asymptote, y is equal to 0, which is pretty much the x-axis, which not pretty much, it is the x-axis. Okay, so notice now that your graph is now divided into like 6 segments, 6 partitions, you know, 1, 2, 3, 4, 5, 6. There's usually sometimes a general pattern, and I kind of maybe want to tell you right now. So sometimes either you'll have graphs here, functions representing themselves here, like they kind of like flip-flop, you know. down, up, down, or sometimes they're represented over here on these segments, up, down, up, over here. I will also let you guys know that sometimes in the middle, if you do have like a middle segment, sometimes it doesn't follow the horizontal asymptote, meaning that it will actually break through. Sometimes a horizontal asymptote is meant for these outer portions over here, so just kind of be careful. That's why we're going to plug in some numbers in a little bit. Okay, anyway, let's do now step 3. Step 3 is to find our x-intercepts. And to find our x-intercepts, we're going to set f of x equal to 0. Okay, so 0 is equal to negative 4 over x squared plus x minus 6. The good thing about this is, let's go get rid of that denominator. How? We're going to multiply both sides by x squared plus x minus 6. X squared plus x minus 6. I like these because those undo each other, and then the right side, the left side, is going to be 0. 0 is equal to negative 4. This is false. Okay, so therefore there's no x-intercepts. And I hope that makes sense, just because, I mean, it doesn't work all the time, but just because we have a horizontal asymptote at y equals 0. Okay. Like I said, sometimes the middle portion will not follow that. Sometimes there will be an x-intercepts. That's why we have to do these additional steps on getting those. Okay. All right. Anyway, let's get the y-intercept. We're going to plug in 0 for x, or set x equal to 0. So let's go ahead and do that. F of 0 is equal to negative 4 over 0 squared plus 0 minus 6. This is negative 4 over negative 6, and then this is going to be positive 2/3. This is a point, okay? Because we plugged in 0, our input, our output is 0, 2/3, okay? And I think I'm going to mark that in light green, even though I have my projector doesn't project too much color. So 0, 2/3. Just do this to your best of your ability. Somewhere over here, I guess. Okay, so that's your y-intercept. All right, and then to kind of fill in where you would see other places of the graph, plug in x values near the vertical asymptotes. Okay. Oh, sorry. So I've given you guys a general pattern. So if it's done correctly, then you could either have a down, up, down over here, or you can have an up, down, up over here. But sometimes, again, this middle portion might break the horizontal asymptote. And the horizontal asymptote is usually meant for these outer portions. But that's why we plug in a couple of values. Let's go plug in, 1. And the reason why I said 1 is because it's near the asymptote x equals 2. So let's just plug in 1 and see how that goes. 1 squared plus 1 minus 6. This is negative 4. 1 plus 1 is 2, minus 6 is negative 4. And then this is 1. So 1, 1. Okay. All right, so I guess right over here. And I think let's go plug in negative 1. Okay. Negative 4 over negative 1 squared plus a negative 1 minus 6. So hopefully it's just light calculations. Negative 1 squared, quantity squared is going to be 1, minus 1 is 0. This is negative 6, so this is going to be 2/3. Okay, negative 1, 2/3. All right, so, and then I'm plotting these in black. So negative 1, 2/3, which is right over here. Okay, and just in case, I think I'm going to plug in 2, because sometimes, again, like I said, it could go like this, or sometimes it could go like that, kind of like almost like a tangent graph. So I'm just going to plug in 2 just in case. There's like a slight difference to that. So negative 4, negative 2 squared, plus a negative 2 minus 6. Okay, negative 2 times negative 2 is 4. 4 minus 2 is 2. 2 minus 6 is negative 4. Okay, so this is going to be negative 2 comma 1. Okay, that's nice. Okay, so now we know that it's not going to break the horizontal asymptote. So I can just kind of make my curve over here like this. Okay. These outsides over here normally do not break the horizontal asymptotes. Okay, so if you want to plug in a little bit more numbers here, you guys can, just to make sure. But otherwise, now that we know that it's going to be in the top middle, we're going to be expecting your representations to be on the bottom left and on the bottom right, okay, of this. So let's go ahead and plug in a couple numbers just in case we have, just in case. Okay, so let's go ahead and do that. Let's plug in 3, I guess. 3 and negative 4, and then I think we'll be done for this one. Yeah, so let's plug in 3. F of 3 is equal to negative 4. 3 squared plus 3 minus 6. Okay, so 3 squared is 9. 9 plus 3 is 12. And then 12 minus 6 is going to be 6. So this is going to be 3 comma negative 2/3. Okay, and actually our predictions, our patterns were correct. So 3 comma negative 2/3 is somewhere over here. Okay, for time purposes, go ahead. For time purposes, I'm not going to plug in 4 or 5 or even 2.5. So if you really want to make sure, go ahead and plug in 7. And I think like if you plug it in, then you're going to have like some sort of fraction that's near already the horizontal asymptote. But we can use now the asymptotes and use it to guide us to see, to help us draw this function. Okay. I think I'm just going to do one more. I'll plug in negative 4 and then see where that goes, just to solidify that it needs to go on the bottom left. Okay, so negative 4 over negative 4 squared plus negative 4 minus 6. Let's go ahead and do that. Negative 4 times negative 4 is 16. 16 minus 4 is 12. 12 minus 6 is 6. Okay, so it's going to be negative 4 comma negative 2/3. So now this also solidifies that we're going to have this graphical representation on the bottom left. So negative 4 comma negative 2/3 is over here. And then that's going to be that. Okay. All right. So that is our graphical representation of f of x. You guys can stop the video after I say a couple things and go ahead and start doing problems. So you may not start do numbers 3, and again, it's up to you if you just want to just move on into the notes, 3 all the way up to number 20. Okay, so number 3 goes in the same way, and then 4, 5, and then 6. When you guys get down into number 7 to 20, these you do not graph. It's just only asking you specific things. So say for example number 7, it's only asking you for the vertical asymptotes of each. So, and I've kind of given you guys a hint, factor the denominator and set it equal to 0. We might as well just do number 7 right now. So x squared minus x minus 2 is equal to 0. Let's go ahead and factor that. X minus 2, x plus 1, does that work? Does that work? Maybe, yes, yes, yes. Okay, negative 2 plus 1, okay. And then after that, x minus 2 is equal to 0, x plus 1 is equal to 0. So your 2 vertical asymptotes are going to be this. Okay, and then that's it. That's it for number 7. Okay, so identify the vertical asymptotes. Number 11, starting from number 11, identify the horizontal asymptotes. So you got to match the degrees. Okay, so only do that. There's no graphing whatsoever from number 7 all the way to 20. It's only asking you what it's asking you. Okay, identify the x-intercept, so set f of x equal to 0. And then go from there, multiply both sides by the denominator. And then again, sometimes you might not have x-intercepts depending on the equation. And then number 19, set x equal to 0 for y-intercept, so f of 0. All right, you guys, it's up to you. You can move on to the notes, or you can actually start tackling numbers 3 to 20.